Hi everyone, thanks for checking in today. Today what we're going to do is we're going to design a phono preamplifier. Turntables are making a comeback, a lot of people are buying records, vinyl fever is catching on, and I thought it would be cool to design a phono preamplifier that is retro in aspect. It captures the absolute best sound that was available from the 70s and the 80s. As you know, there were many great audio designs in the 70s and 80s. Much of that equipment is still sought after today. And so what we're going today to do is to design a phono preamplifier that uses the best of the available circuitry that was available in the late 1970s and early 1980s. And we're going to use an integrated circuit for the front end of our phono preamplifier, and we're going to use a passive equalization circuit. And the amplifier chip that we're going to use is called the LM381A. It's a really nice integrated circuit designed by National Semiconductor, and it has exceptionally low noise voltage and a 1F noise frequency of about 1 kilohertz, which means that low frequency noise is the low frequency noise source is going to turn over to around 1 kilohertz. Op amps have, or actually transistors in general, have a characteristic where the noise voltage and current starts to rise at lower and lower frequencies. And you want the 1F noise frequency to be as low as possible so as to minimize the amount of low frequency noise in your circuit. 1 kilohertz is not an exceptional value, but it's a pretty doggone good value. It's very, very good. And the total input noise density is around a microvolt, which is pretty doggone good. I designed an amplifier using this circuit back in the late 70s myself. And what we're going to do today is to recapture a little bit of that. We're going to use a coupling capacitor because our chip uses a 32 volt supply, and it's designed for single-ended power supplies, which means our negative is going to be ground referenced. And here's our 3 and pin 4. Both need to be connected to ground for our amplifier. This here is pin 7, which is our output for channel 1. There's actually 2 amplifiers on this chip. It's a 14-pin dip, and there's 2 identical phono sections. But we're going to use one phono section for this. Input pin is pin 1, and the LM381A is kind of unique in that it has 2 different negative inputs. One negative input is on pin 2, and we're going to ground that one because that's the differential input. The other negative input is the single-ended input, which means that we have a single-ended input stage. This is actually the emitter of the transistor that's connected to pin 1. Pin 1, the base, the base goes to here, and the emitter goes through some circuitry and is connected here so that we can connect our feedback point down there. What that also means is that we're going to need a bias source. We're going to need a bias source to set our DC bias, and that's typically a 2.5K resistor as recommended in most application notes. Now for our AC connection, our AC feedback, we're going to use I believe a 31.9K resistor, and a 1K resistor. in our AC feedback circuit. And we'll use a 220 microfarad cap for the AC feedback, 1K. And this combination, 31.9K resistor and 1K resistor, is going to give us an overall AC gain in the circuit of right at 30 dB, which is really good for a phono preamplifier. Our input coupling cap doesn't need to be very big, but we might as well use, well, here's the thing. When you're designing a circuit, you can go two ways. You can design everything to be optimal in terms of, I'm going to use only what I need here. For example, here, I only really need a 1 microfarad capacitor there. A 1 microfarad capacitor with the 50K input resistance of this chip is perfectly adequate. However, when you're buying things, when you're actually making something, sometimes it's better to consolidate. And since we have to bias the circuit, for example, here, our chip has external compensation, and it has a bias pin. And we need a voltage divider to set our bias on our chip. And that means at this point here needs a bypass cap. And this bypass cap needs to be right around 10 microfarads, but we can get by with 6.8 microfarads, which means we can use a really good polypropylene 225p Panasonic orange drop capacitor. So what we're doing, you see here, is we're designing for production. We're designing for quantity. If we use 6.8 microfarads everywhere, we can even use a 6.8 microfarad to couple the output of this here in a minute. And you see, then we only have to buy one type of capacitor. When you buy one type of capacitor, you increase the quantity of that capacitor. So rather than buying maybe 6 1 microfarad capacitors or 10 1 microfarad capacitors and 5 6.8 microfarad capacitors, the difference in price between them is only about 50 cents. And if we just buy 6.8 microfarad capacitors, it's more than adequate. It exceeds our nominal design needs, and it lowers the price that we pay for each individual capacitor because we're buying them in quantity. So what we're going to do is, basically, we're going to use 6.8 microfarad capacitors a lot in this circuit. Our external feedback compensation needs to be around 300 picofarads. And that gets us our basic phono design. We're going to use a 100K here, and we're going to use well, actually, we're going to use a 150K here. And we're going to use a 51K here. Again, we're using 1% resistors everywhere. And then for our RIAA equalization circuit, we're going to use a 27.4K capacitor or resistor here. And that's going to go off to a resistor and capacitor network here that sets one pole of our RIAA response. And that resistor is going to be 3.9K. And this capacitor is going to be 0.08 microfarad. Now, the thing is, you can't get a 0.08 microfarad capacitor. It's not a standard value. But, again, going back to Panasonic, we can get a 0.068 microfarad capacitor, and we can get a 0.012 microfarad capacitor, which gives us our 0.08 microfarads, you see. And then we have our other pole capacitor here. And that is a 0.027, which is also a standard value. So using standard 3% tolerance capacitors, there we have our phono preamp all the way up to the buffer. Now we're going to need to add a buffer to this, and apparently it's going to take us another sheet of paper to do that, but we'll get to that in a moment. You see, now we have, well, let's put our loading network there for our cartridge, which is typically 47K. And there we have a complete phono preamplifier with passive RIAA equalization. And we're using one of the best integrated circuits that came out of the 80s. We can capture the vintage sound, quality sound, a very, very, very good phono preamplifier. Now for our output, all we need to do is use a JFET op amp, and that's pretty easy. Because we have 30 dB of gain in our first stage, realistically, we're not going to need much more gain than that, because most circuitry design nowadays is pretty sensitive, because we have 5 volts for everything, just about. Equipment has gotten very sensitive to low voltages. Some DACs or some A to D converters won't even allow you to input more than about a volt to a volt and a half. And if we have 30 dB of gain on the input, that means that a 3 millivolts, we're going to have about 3 millivolts input to our 3 millivolts from our cartridge here. We're going to have about 120 millivolts here, which works out quite well for most modern equipment. So all we really need to do is buffer this, which means we can use a simple unity gain buffer stage, and that can be a TL082, which has a higher noise voltage, but because it's coming after our primary gain stage, it's not going to contribute that much to our overall noise in our circuit. And at the input of this, of course, because this is coming from, this is going to be right at, we want to set this bias so that this is at about 14 volts right here. That will allow us to swing basically 14 volts or about 12 volts in either direction with our 32 volt rails, which gives us a really good overhead. It gives us a really good overhead for our input here. It would take several hundred millivolts to overload this preamp stage, which is what we want with a cartridge, because remember, RIAA equalization boosts the higher frequencies. Now, and not a lot of records have a lot of high frequency content. However, some records have a tremendous amount of high frequency content, and that content is going to be boosted by 40 dB relative to our base frequencies. That's so that the cartridge doesn't skip out of the groove. The grooves would have to swing so far back and forth without the equalization that phono cartridges would be basically unable to track it. So RIAA equalization reduces the base frequencies and increases up to the mid-range, and there's a step at the mid-range, and then it increases further into the treble range. So if we have something with a lot of high-frequency content, which can be had quite often nowadays, especially with so much synthetic music, which I personally happen to love. I love synthesizer music. I'm from Detroit, and I love trance and And basically, I was fortunate enough to grow up in Belleville, which is the home of techno. Techno music was essentially invented in the Detroit area in the 1980s when I was a teenager. If you go on YouTube here and you type in Belleville 3, you'll see three fellows that I went to high school with. It was a very good time to be alive, a great time, and that still sticks with me to this day. I love techno and trance. I love Armin van Buuren. I love deadmau5. I love Helene Vogelsinger, who's very active on YouTube here, and you should check out her channel. Helene Vogelsinger is wonderful. She's a very accomplished synthesist, and her videos are always very mysterious and moody and thoughtful. Anyways, getting back to this, we have our 14, well, it won't be 14 volts here. Well, I guess it will be. It'll be 14 volts here. It'll be 27.4K. Yeah, it'll still be 14 volts right here. What do you know? Anyways, so we need a coupling kit for the input of this. And again, we can use a 6.8 microfarad because we're just buying a bunch of them. And we have that we can have a direct coupled output from our TL082, if not for the fact that the TL082 is also going to be running from 32 volts or probably less than that. Probably we'll want to put another 6.8 microfarad cap here. And we're going to feed this from a voltage divider. So that right here, I think the TL082 is rated for a 24 volt supply. So we're going to have 24 volts here, which we can work out the math later. I don't have a calculator handy, but anyways, we want to choose these two resistors. This will be 100 ohms, and then we'll choose this to be, let's make that a 1K ohm resistor to minimize our current flow. And so this will be a 1K resistor, and this will be whatever we need to drop that 8 volts so that this here is running from a 24 volt supply. And then we have our ground for our FET, and there we go. We've got our input stage, we've got our output stage, and we've got the beginnings of a phono preamplifier, which I will talk about in much more detail in coming videos. I hope you'll tune in for those. I want to thank you so much for checking in today. I hope you enjoyed this video, and I'll see you again soon.